6.1, exponential growth and decay. General growth or decay formula. It's not talking about that. It's talking, we're using the formula. A equals P times the quantity of 1 plus or minus R to the T power. A is standing for the final amount. P stands for the principal, or the original amount. The number 1 stands for the number 1. R stands for your rate as a decimal. What does T stand for? Time, in years. Now there's that plus or minus. What type of problem do you think talks about plus? Growth. What type of problem do you think is the minus? Decay. If something is growing, we use plus. If something's getting smaller, we use decay. It does not have to be, as you're thinking, decaying bodies. Yeah, it can. Like the one part where you use this is, you ever wonder, how do they find out, like if they find bones, how do they know how old those bones are? Carbon dating. By finding out how much carbon is left in that, it's exponentially, carbon decays exponentially. They can put into the problem, find out how many years old it is, approximately. Here. Do you still need that back page? Okay. Your mistake's not going to be the plus and minus. Your mistake is probably going to be the R. And I'll show you where. Our first problem. The population of a city is 152,494. The population is decreasing at a rate of 1.5% per year. What would the population be in 10 years? What type of problem are we talking about? Decay. It's decrease. So what formula are we going to use? The minus. We're going to use A equals P times 1 minus R to the T.
I got a question. Is it always going to be this easy to point out? Like, that's how you got it?
You just plug and chug. But you have to put things in the correct order. We're looking for the final amount. What's my original amount? 152,494. I know what you're trying to say. 1 minus. It is not 1.5. That 1.5% has to be written as a decimal. 0.015. Why? The percent in decimal form is 0.015. Move the decimal place over 2 spots. And my T is 10. Now, why do I have a 1 here? That's 100%. 100% is the whole amount, right? And we're subtracting 1.5%. Just like if we were talking about sales tax, it would be 1 plus 0.06, because that gives you 106%. You need your calculator for these. Without a calculator, it's very difficult. Just substitute it right in. All you need to write, 152,494, parenthesis, 1 minus 0.015 parenthesis caret 10. Now, you have to make sure you type it in correctly. When you do these problems for homework on your tests and quizzes, write out the problem, then use the calculator. A lot of you want to get lazy and just go directly from the problem to the calculator and you write down an answer. And I can't see your mistake. If I see this correctly right here, I know the mistake has to be in the calculator. Yes. What are we talking about here? We're talking about people. So I have, what? 131,103.7341. So A is approximately what? 131104. Because you can't have a part of a person. You need to think, what am I looking at in this problem? Sorry, I haven't used commas in I don't know how long. The rate at which caffeine is eliminated from the bloodstream of a child is about 25% per hour. So when you drink one of those energy drinks, whatever it is, as a child, every hour you lose 25% of that caffeine. Even if you're sitting on the couch, it goes through your bloodstream. It's filtered out of your system. All right, a child drinks a cup of pop and the caffeine in their bloodstream reaches a peak level of 30 milligrams. Predict the amount of, to the nearest tenth of a milligram, the amount of caffeine remaining after 1 hour and after 4 hours. Try to set up both. Okay, setting this one up for 1 year. Or sorry, not 1 year. 1 hour. For 1 hour, A equals, okay, what's the original amount of caffeine in the system? 30. 1, am I going to add or subtract? Subtract. I am decreasing the caffeine in my system. How fast? 25%, which means 0.25. How many? Okay, years, but this is talking about hours, so I just use 1. All I asked at first was to set it up. For 4 hours. A lot of people want to think, well, if it's 25% per hour, 25, 25, 25, 25, it's now out of my system. A equals 30 times 1 minus 0.25. Now it's a 4. I know it's usually in years, but here in this problem, this is talking about 25% per hour. And this one was talking about decreasing per year. As long as I'm talking about years, hours, it doesn't really matter. If it's talking about months and I'm talking about years, you got to change them so they're the same. How? If I'm talking about years, how do I change years to months? It'll tell you one or the other. Like it might say 25% per month. How many after 5 years? Instead of 5 years, you would use 60 because that's. I use the calculator since I've set them up. All I type in is 30. If you want to and you know how to subtract, what's 1 minus 0.25? if you, just be careful when you take little shortcuts. Okay, to the first power. I don't need to write it to the first power. And it is, so this is after 1 hour, 22.5 milligrams are still in the system. Now the nice thing about these calculators, second enter, retypes everything I typed. Just change it to a 4. Now, I want my answer in the nearest tenth, so it is 9.5 milligrams. It's not to 0. Why? Because it's losing 25% every time. So if I was at 100%, after 1 hour I'm at 75. Now I take out of that 75 another 25%. So it's 25% of that 75. It's just like those after Christmas sales where people think all Christmas stuff is 75% off. But if I have this coupon, it's an additional 30. No, the store does not owe you 5%. You take off 75%, then you take off another 30%.
When is it going to be all the way?
Sorry. Yeah. We can figure out when would it be entirely out of your system later. Right now, we can't find out. The only thing we can do, I take that back. Well, don't do guess and check. Put in the calculator. 30 times 0.75 to the x. Because it's changing every single hour, right? Look at the table. So after 1 hour, there's 4.
Holy crap, it's over a day.
Yeah. So, okay, if we look at tenth, it's over a day before it's out of your system, just out of 1 cup of pop. Yeah. So if I changed it to if I had 2 glasses, it's now 60. Second table. I mean, it's still in there. Okay, this is mathematically, not actually. But if you look at it, okay, now it's starting to get fully out of your system after like 2 days. Just because you do something now doesn't mean it can't be traced later down the road. Okay. Some tea there is. Here's this problem. A bacteria population grows rapidly and doubles every hour. There is an initial population of 250 bacteria. How many bacteria are present after 3 hours? For the formula, A equals, I start with 250. Okay? You know it's 3. What's happening every single time? Okay, it's doubling. So what's going to be in the inside? 2. Because it's, you got to think, 1 plus 1 is 2. You're doubling it. 1 plus 1 is 2. Just like if I was tripling it, it'd be 1 plus 1 plus 1, which is 3. Just so all I do is I can even use the calculator again on the graph. 250, 2 to the x. Well, I'm using the table. Second table. All right. Table set. I'm going to start at 0. second table. So after 1 hour, or at 0 hours, there's 250. After 1 hour, 500, then 1,000, and then there's 2,000 after 3 hours. Yes, it grows really fast. It's exponential. What's that? Right. That's the way bacteria grows. Questions on this section?